And welcome everybody to the Daily Space Weather! Who remembers when that used to be our intro? Today we're talking about a rising active region, coronal holes, and whatever happened to stereo B. We'll get to it. First thing we're going to do is take a look at the sun here in 335 angstroms. We see two sunspot regions there. They're both significant. The trailing one is more significant in that it has opposite polarity umbre. It's sunspot 2795. And this active region over here may indeed be a sunspot. If I had to guess, I would think it probably is. And more on coronal holes in a bit. The radial flux of the 10.7 centimeter variety is at 88 solar flux units. By the way, I'm your host, Dan, aka smAsho. Let's continue on with the data. Here's the 1-year chart from Solon.info of the 10.7 centimeter radial flux and the AP planetary index, sunspot number, and solar polar fields. And here is a graph of the sunspot number progression and the 10.7 centimeter radial flux, which for you new viewers out there, thanks for tuning in, by the way, is directly proportional to sunspot number, and you can see how similar those graphs are. Here's another view of the sun here. It's 131 angstroms. We'll show you the full disk here. Let's speed that up a little bit. We don't want the video to be too long, as there's lots of things to talk about. And you don't necessarily need high levels of solar activity to have exciting things to cover. So we'll take a quick look at the fields here. Here's 193 angstroms, and you can see this coronal hole right here. We're expecting a wind stream from that in about a day and a half to 2 days. There are the magnetic fields real quick. There's 304 angstroms. And let's take a look at what's going on at Lagrange point 5, which is where stereo A is located. So here's the view from stereo A. And we are expecting some coronal mass ejections to happen here. A minor event looks like it's actually unfolding now on the Earth side. We'll probably make another video later today to see how that unfolds. Don't be surprised to see one on the non-Earth side. Also, again, new viewers, the Earth is out in this direction from the viewpoint of Lagrange point 5. Let's talk about stereo B very briefly. Stereo B is no longer functional. And if you're wondering what happened, well, it got struck by a bunch of plasma. And let's show you what went on at stereo B. So I'm just going to bring up the movie here just to give you an idea of how this works. We're going to go back to August 31st. And we're going to show you what went on at stereo B. So you can see a bunch of plasma looks like it's headed toward the aperture. And let me advance this to a slightly later date here. We'll move this ahead to September 2nd. Just give that a minute to load. We are streaming live. And you can see that strike on the aperture there. That's an indication that protons struck stereo B. And later in the month, this thing went out of commission, probably because of this massive stream of electrons that was following that stream of protons. So I'll advance this a little farther here, 2 more days ahead. And you'll see another major strike. There were a series of coronal mass ejections. We'll do a more in-depth video about this later. I just wanted to give folks a little view of what went on out at stereo B. NASA says a hardware anomaly occurred. I believe it was on the 17th of September that year. And if you're wondering where that's located, it's located out here at Lagrange point 4. So the magnetometers still work on stereo B, but the imaging systems are toast. So there's a little insight into what went on with stereo B. Next, we'll look at some more HelioViewer movies here. We'll save the in-depth close-up ones for the end of the video. There's the magnetogram, And you can see those sunspots 27, 94, and 95 remained pretty stable here over the past day. I'll let it play through a second time for your viewing pleasure. As the magnetic fields are the most important aspect of the sun, and while these images like this of ionized helium are visually stimulating, the magnetic fields are really what we need to be studying. We'll get more into it during the cosmology segment today. We'll talk about some heliospheric cosmology. And before we move on, I'd like to check the life of the stream here, and it looks like things are doing just fine. So let's move on to talk about some other stuff here before we get back to data. First of all, our own website. If you haven't checked it out, it's smAsho.com. You'll be redirected there if you go to smAsho.org. You can find our social media links there. So follow us on social media as well. Consider becoming a patron. The link to our Patreon's right there. It's patreon.com/smAshomash. You can also check out the forum and the stores. We've been a little bit inactive as we've been very, very busy for the holidays. Thanks to our new subscribers over at YouTube. And please take a moment to press like and subscribe. If you're viewing on BitChute, come over and subscribe over on YouTube and vice versa, because we've got exclusive content on both sites. So look for more exclusive content coming soon to BitChute. Thanks to our new subscribers over there. If you haven't subscribed over on BitChute, please do so. We're almost at 300. Be the subscriber that pushes us over the limit. I mean, over the 300 subscriber mark. There is no limit. Here's a diagram of the solar system. I like to use the planetstoday.com. It provides a nice, simple diagram of the solar system. And there's where things will be in a week. It'll be very close to full moon on New Year's Eve, by the way, making for a bright night if you've got clear skies. There's where things will be on January 3rd. And here's a star chart real quick just to show you the ecliptic and the way the sun will be setting in Gemini today. And if you're up before dawn, you may see Venus, the third brightest object in the sky, my favorite planet. And thanks again to our subscribers over at Twitch. It's twitch.tv/smAshomash. They've got great software there for streaming, as well as a great mobile app that you may want to download. It'll notify you when we go live, such as we are now. Twitch.tv/smAshomash, the primary streaming platform at the Smash News Network. And let's talk cosmology. Before we do so, I'd like to thank our patrons, the true source of funding for the content. It's patreon.com/smAshomash. Please consider becoming a patron. Increase the probability that these videos will remain free and publicly visible. Again, patreon.com/smAshomash. Thanks, patrons. Thanks to our newest patron. If you become a patron, please do so at the $3 per month level. And also keep in mind, if you're unwilling to even send us a couple bucks per month, we make public posts regularly. So follow us on Patreon, even if you're not willing to contribute. Now, I'd like to just cite the paper that's listed at the top of the Neil Gorell Swift Bat X-ray Observatory. So we talk about that regularly, the Neil Gorell's Swift Burst Alert Telescope X-ray Transient Monitor. We talk about it regularly because it's a great link to various objects. If you haven't read the paper, please do so. It tells you all about the wavelengths that we're looking at the Burst Alert Telescope and the sort of the history of it and all of that stuff. It's linked right at the top of the page, right here. This paper right here from 2013. So check that out. Next, we're going to roll a quantum random number between 1 and 1031 with our 1031 sided die. And today's quantum random number is 132. So we'll randomly take a look at this object, 132. It's 3C111, which is a Seyfert 1 galaxy. It should look great. Let's take a look at that. There are the X-ray transients from 3C111. And you can see it's a very consistent X-ray source here on the historic monitor. That is data going back to the year 2005. There is the last 30 days as well as the 3-day chart of the X-ray transients for that. And let's take a look at it visually. Again, we are streaming live. Bear with me a quick moment here. We'll go to Aladdin Light and we'll view this on the Chandra X-ray telescope. Let's hope it's got images, and there it is. So it's a Seyfert galaxy, and Seyfert galaxies are active galactic nuclei, where the jet is pointed significantly enough toward the Earth that it appears as a very bright nucleus. Now this one appears to be an elliptical galaxy. Let's take a look at it on the 2 mass, see if we can see a little bit more detail, and indeed it is an elliptical galaxy, which tend to be the largest galaxies, by the way. They just look like giant spheres. So that Seyfert galaxy there, 3C111, is today's cosmic object. And again, you can view that yourself if you want to look up the transients of that. It's, what is it, number 132 on the Neil Garrels Swift Bat X-ray Observatory, galaxy 3C111, the massive elliptical galaxy. Now let's talk coronal holes. What we're looking at here is a massive coronal hole. And the dates of this helioviewer movie are May 31st, 2013 through June 4th of 2013. And that coronal hole right there is very significant. We'll tell you why in a minute. Coronal holes are significant because they represent a cooler region on the sun, where we don't have all of this pesky plasma blocking our view of the chromosphere. And we got this cool region here which exposes the sun's magnetism, where instead of the sun's magnetic field lines looping around and ending back on the chromospheric surface, the field lines come all the way out, deep into space. That's very important because it tells us things about solar activity. It elicits information about the solar cycle that we may not otherwise know. And so that's part of the reason why coronal holes are so important. They also impart a high-speed solar wind, as they tend to blast out a beam of protons. So they're the source of the steady coronal hole high-speed wind streams that we observe regularly. And more about this later. We got to do a special video just about solar cycles and how coronal holes are important to understanding them. So this one here, this is Coronal Hole 571. So this produced an AP index of 132. It produced a significant geomagnetic storm here on Earth, a KP of 7. And this went all the way around the sun. So this it was originally known as number 568. So it caused a second wind stream as well. It was also 564. So it actually was on the sun for about 90 days there. And it indeed moved from a northern to a transequatorial. So that's a significant coronal hole, and I just wanted to cite that. Here's another significant coronal hole. This is from July 18th, 2013. So the same year there, another massive coronal hole erupted in the northern hemisphere later. And again, this gives us insight into the solar magnetic fields. And so here's an article about it if you want to read this one. This one's entitled Large Coronal Hole Near the Sun's North Pole. Have a look at that. And here's the one that we showed you on the helioviewer movie. This is from 531, May 31st to June 4th. And you can see how significantly different the sun's B field, shown in blue, is as to how it looks at solar minimum. At solar minimum, the B field is just very basic, like this, looking like a football shape. And you can see that is a North Pole-oriented coronal hole that extends all the way down past the solar equator, making it what we call a trans-equatorial coronal hole. And if you want to look up more of these significant coronal holes, you can link to this page at solon.info, the coronal hole history. So if you head to solon.info/solar and you scroll down, down here, you'll find this coronal hole history going back to October of 2002. So check that out. More about coronal holes in a later video. We'll do a cosmology segment specifically about it, one not even integrated into the Daily Space Weather video. And thanks again for tuning in, Precious Lights. Good morning. Yes, I really drink cayenne pepper and indeed cocoa in the coffee. Precious Lights asks, do you really drink cayenne pepper in your coffee? And indeed right now, it's in there. So yeah. I like my dining experience to be so spicy that it causes a religious experience to happen. I like to see God when I consume foods. And the cocoa, by the way, increases the nitric oxide content, increasing your blood oxygen levels. It's a performance-enhancing substance that's not illegal. Let's get back to data. Next, we've got the real-time solar wind here at the Smash News Network. So the real-time solar wind, we just saw some changes here happening in the solar wind density, which should be reflected in the magnetohydrodynamic pressure. We'll show you that in a minute. Here is the current state of affairs with the density. We just saw an increase, as I did show prep. Current density is around 8 protons per cubic centimeter. Current solar wind speed having come off of its highs. Now at still elevated levels, 440 kilometers per second approximately. Let's take a look at the magnetohydrodynamic environment after we look at the KP index, which is currently at 1. So here's the geospace magnetosphere movie. By the way, that KP index is a measurement of global geomagnetism. And this is 4 hours of data. You should see the pressure come back up here toward the end of the movie. And indeed, right there, you see that increase in the solar wind density reflected in pressure in nanopascals. Next, we're going to look at ground magnetic perturbations, changes in the Earth's B field here a little bit closer to home. We see pulses both in the southern Indian Ocean and in the Pacific Ocean. And since that refresh will let it play through again, that's 4 hours of data, courtesy University of Michigan. And if you want to read about the space weather modeling framework, just scroll down to the bottom of the page there. On either geospace magnetosphere movie, click on details and click on the link to the space weather modeling framework. It uses a lot of variables to create this model. And again, that's 4 hours of data. We don't see any significant shifts here in the proton flux, as we haven't seen any coronal mass ejections in quite a while. I guess we're pushing about a month now since we've seen increases in the proton flux. And we've got an X-ray flare happening as we do the live stream. So there you can see that little B-class flare that kicked off. It looks like it's already peaked, and it hasn't. It's just like a B2 level, it looks like. I think that's a B2 level. Looks like B1.4. No, that's I think it's a B2 level. I won't really worry about it. It's quite minor. And here's the 3-day chart of the GOES magnetometer, and we're seeing spiky readings here as the Earth is in the process of crossing into the other. Why did the Earth cross the heliospheric current sheet? To get to the other polarity. Yes, science jokes. Magneto-heliospheric hydrodynamics science jokes. So yeah, there's that. And we're probably already back in the North Pole-oriented current sheet. Here's evidence of it. And you can see the Earth's potential field surface source line here, probably already in the North Pole current sheet, shown there in green. Keep in mind the data is 1 hour and 10 minutes old. The magnetic environment can change with absolutely no warning. So here's the current line of sight coronal hole plot. And this is the same plot that we showed you with those massive coronal holes. And you can see the Earth's B field here is much more equatorially oriented, as it is around times of solar minimum. And we've got actually 2 coronal hole systems, one south pole oriented there near the equator, and a north pole oriented one also near the equator. So we've got actually 2 separate coronal hole wind streams coming out. They may form a co-rotating system where they can actually interact with each other. And here's just a different view of the same thing here. It also shows you the poloidal fields and the solar magnetogram. And here's the last magnetic plot we'll show in today's daily space weather video. It's the coronal magnetic field plot. And the solar corona, the sun's atmosphere, is quite a chaotic environment. And you can see those purple lines pointed right toward you, the viewer, right here. And those are the coronal hole potential field surface source lines, which are including the Earth in all likelihood at this point in time. Next, we'll talk electrons, which are capable of charging up satellites. Now, typically most satellites, especially the more modern ones, will shut themselves down inducing what we call a CCD bakeout for things like the SDO. That's the bakeout of the charge couple device, where it senses too much of a charge and it shuts itself down before taking damage. We don't see any charging hazards. Here's the 1-year chart of the electron flux, and that's also courtesy Solon.info. Here's the 3-day forecast according to Noaa, and we're expecting a fairly flat level of electron flux here. I would tend to agree with this forecast. I see no reason not to. Here's a 3-day chart of it, and we just tinkered with warning levels, which are represented there by the red dashed line. That's 1,000 pulse flux units, and our Patreons probably know all about this, as we regularly send out alerts to our patrons for everything from solar flares to coronal mass ejections to electron flux, as it gives you insight into things like GPS errors. So here's a visualization of the air column which shows you the electron flux. It shows you actually the electron density here. And this is going all the way from the upper thermosphere where GPS satellites are located down to your handset. And we see minor anomalies there over Antarctica and North America. So this is a reason to keep Wi-Fi sensitivity turned on in places like North America at times like this, as you could find yourself thousands of miles off with a GPS signal alone. So here's a diagram of the Van Allen belts, and this is what, when we're talking about electrons, we're talking about those yellow areas there surrounding those red areas, and in between those are the Earth's plasma spheres, where there's a whole host of different molecules hanging out, suspended by those fast-moving bands of electrons known as the Van Allen belts. Keep in mind the distances on this are in miles. For example, the International Space Station is at a low Earth orbit at 230 miles, whereas your GPS satellite is at 12,500 miles. The SDO is at 22,000 miles, and the SOHO spacecraft is at Lagrange point 1, which is more like 1,000,000 miles. This one is listed in kilometers. And so this is just another diagram here. It also shows you the penetration of electromagnetic radiation from the sun into the atmosphere. For example, how visible light and infrared radiation make it all the way to the surface, whereas X-rays are primarily absorbed by the mesosphere layer. And also you can note that red F right here on the right. That is where the GOES 16 is located. It endeavors to make its measurements at the F ionosphere layer. Those other letters were D and E layers, lower altitude layers of the ionosphere. So here's a visualization of just the F layer, and it's looking less anomalous than yesterday. Some anomalies there in the southern hemisphere, though. Some minor charge ups there at nighttime. Nothing to write home about. Here's the latest image. Wait for it. Wait for it. 11:45 Universal Time. And actually, it's getting anomalous as we do the video. So a bit of a charge up there in the southern hemisphere. Next, we'll look at volcanoes as we get into more like earthly subjects. Klyuchevskoy is erupting, producing a 22,000-foot ash plume, and now Karimsky back on the list as it's producing a 17,000-foot ash plume and exploding. Suwanosejima, flight level 040, a 4,000-foot ash plume there. Popocatépetl, exploding, 20,000-foot ash plume there. Fuego likewise exploding, 16,000-foot ash plume. Sangay, down in Ecuador, as well as Revenador in the same country, both exploding, producing a 22,000 and 15,000-foot ash plume respectively, and we're unable to detect whether or not Sabancaya is erupting. Please do not attempt to do the triple Lindy over Sabancaya. It could prove unhealthful, and we need the viewers. Next, looking at windy.com's pressure maps. And we see some oddities here. It looks like yesterday's GFS forecast never panned out. Check out the large and in charge low pressure system there over the northern Pacific, as well as over the northern Atlantic. Let's see what they're expected to do via the GFS forecast into tomorrow. There's where we expect it to be according to the GFS forecast tomorrow at noon. High pressure dominating most of the eastern portion of the U.S. and indeed most of the U.S. period. Let me rock that back and forth to show you the expected movement by the GFS. Stagnant low pressure system there over northeastern Canada. And check out the sudden southern dip of that low pressure system there over the UK, over the British Isles, dipping straight south, right across the English Channel to France. And again, bear with me one moment. I need to check the life of the stream. And thanks again for leaving comments. Precious lights. Largest earthquake of the past 24 was, I think, a 5.7 magnitude, although this one here just came in recently in Turkey. Let's go up the list, starting with this deep quake at Fiji. The deep quake capital of the world. The area north of New Zealand sees the deepest quakes that we ever see. That one is a 4.5 magnitude. And we're just going to scroll up the list here. Many quakes in Hawaii. Let's see what's going on there. There's one at the very southern flank of Kilauea. That one is only at 6.2 kilometers depth. Another deep quake at Fiji. A few quakes in western South America there, including this 4.2 deep quake at 137 kilometers. Here's a deep quake at Japan. So a bit of a deep quake event here. Here's a shallow quake at California at 400 meters above sea level. Another deep quake in the Atacama Desert region of Chile. It's a 4.4 magnitude at 191 kilometers depth. And let's check the location of this Turkish quake. Looks like it may have caused some damage, as it is in a populated area. I see some cities there. Anyway, there's the location of that one in central western Turkey. A 5.5 magnitude. Next, we're going to look at the jet streams here of the eastern world and check out the extreme bend, driving warm air south into Antarctica, perhaps prompting people to say, oh noes, oh my god, Antarctica is melting. Hint, Antarctica's not melting. We've got extreme bends here over the North Atlantic as well as a large portion of the jet stream right here, blowing east to west, which is backwards, and that will affect things like transatlantic flights. It'll cause flights from Europe to the US to take a southerly route instead of over Greenland, and vice versa, as planes can achieve increased fuel economy by taking this route while going east. Anyway, there's the jet streams. We see doubled up jet streams here once again over the North American continent. In fact, tripled up jet streams. And extreme bends as its meridional jet stream flow at its finest. Check it out, all over the place. Next, looking at lightningmaps.org. It's where I go when I hear thunder. And we don't see any terrestrial lightning here in the US. Let's move on to the lightning mapper. And we still see some lightning there in the central Atlantic. Now to the east and southeast of Bermuda. Here's a US Doppler radar map as we get into more meteorological phenomenon. Significant snow over the northern half of the lower 48. And some wintry mix over South Dakota and Nebraska. Here's what's going on in the cloud layer. And it's not quite light where I'm located. Check out all the low clouds here over the Atlantic once again, making for colder days and warmer nights, as the greenhouse effect is all too real when applied to water vapor. Here's what's going on in the water vapor. Speaking of which, and let's make sure that's going full speed to give you the best possible view. And we're going to zoom in here on the Missouri-Kansas border, as there's a stagnation happening right there. Just in the water vapor map. Actually, we'll zoom in on the Arkansas-Missouri border, as we'll show you one bit of weather pornography before we move on to the final views of the local yellow dwarf. So here's the water vapor for that situation. Some massive pressure gradients developing there, as we've got dry mass of air down here and much moister air to the north. Yes, I've used the word moist, so stay tuned for bonus features, folks. We've got the solar intensitygram and the colorized magnetogram to see if indeed that rising region is a sunspot. So let's get to it. Here's the colorized magnetogram. And it looks like sunspot 2795 might have grown. I'm pretty sure it has. 2794 has remained stable. 2795 has grown. And we see an intensification of this trailing umbra here, this North Pole oriented umbra. That has definitely grown in size and intensity. And here's the active region. Not sure if that's a sunspot. Let's take a look at the intensitygram. First, sunspot 2794, there's a close-up of that in high res. And that's actually gotten a little bit more organized since yesterday. And the leading umbra here has gotten less organized than yesterday, but the trailing one has become more organized. That's sunspot 2795. And let's see if we have a 2796. I don't see any dark spots. What say you, the viewer? And here are our final HelioViewer movies. We've got some views we don't always show today. Here's one we do typically always show. And here's me vanishing. This is the 171 angstroms. And you can see the significant coronal holes there to the north and west of sunspot 2794, as well as the magnetic looping behavior of the ionized iron trailing that. It could be 2796. It's too early to tell. Now this one here, this is the 1700, is it 1700 or 1600? 1600 angstroms. This is actually ionized carbon. So this doesn't show you much unless there are sunspots or active regions. And the bright regions show you more extensive amounts of carbon on the sun's chromosphere. So here's a close-up of sunspot 2794 and 2795 in ionized carbon. Just a different view for a little variety on our daily space weather videos. And it looks to me like carbon is being produced. Is the nuclear fusion coming out of the core of the sun, folks, or is it from the surface? Kind of an important question to understand when it comes to heliophysics. And if you ask NASA why sunspots are dark, you won't get an answer. Here's 171 angstroms of the same region. And I think that's it. Oh, we've got the rising region as well. So that's it, folks. We're out. Thanks for tuning in. Remember, stare at the sun, don't drink, no matter how much the government drives you to drink. And if you do drink, don't drive. And since it'll never be now again, may that solar wind be at your back and that COVIDiousy absent from your doorstep.